As you all know, OpenVG is categorized as the application accelerator in the whole Khronos family. OpenVG has been the very first Bezier, it's difficult to pronounce, accelerator API. It's a new class of hardware accelerator for Bezier, not polygons. It is a royalty-free API, of course, because it's from Khronos. Like other Khronos APIs that accelerates high-level engines such as SVG, vector, and font sets from packages, provided as an OpenGL-like programming model. OpenVG nicely accelerates these applications, including GUI, navigation, flashlight, SVG mobile players, and fonts. And for GUI, mobile handsets from Samsung and Nokia uses OpenVG. And they use OpenVG for not only for GUI acceleration, but also for flashlight 4 acceleration, as well as map and font acceleration. And QT, available from Nokia as a developer tool for environment, is rendered on OpenVG. And many navigation applications utilizing maps with font scaling needs OpenVG for smoother look and smoother scaling of fonts. And also driver information. Some driver information displays uses OpenVG for acceleration. And many flashlight content, mostly for games and for kids' educational learning aid, uses OpenVG for on hardware acceleration, as hardware acceleration. And many SVG mobile players are available with OpenVG acceleration, including MMS, DCD, NPM4 laser, and such. And scalable fonts definitely require OpenVG for smoother font scaling to save scaled sets of bitmap data. These are just graphical examples of GUIs utilizing OpenVG. And Nokia 500 was introduced last September as the very first Nokia OpenVG accelerated smartphone. And it seems they wanted to do some pilot launch of OpenVG dedicated handset. I guess it's mostly from complaints from game developers who utilizes flashlight. And Nokia 500 uses OpenVG for, of course, also for GUI acceleration. And there are many OpenVG enabled, digital still cameras and camcorders from major consumer electronics companies are getting available with OpenVG acceleration for GUI and maybe map navigation. And many of web content, ebooks, and educational learning aids for kids now adopting OpenVG for hardware acceleration. And of course, indicators represented by a factory automation monitoring system and maps with scaled fonts and font itself getting accelerated by OpenVG. However, we're facing some complaints from developers and application developers, I would say. Because it's rather a full set of functions and features, most of which may not be fully utilized. And the existence of OpenVG might be confusing developers because we might need to have two separate LSIs or devices. One on OpenGL and the other on OpenVG. Yet, everyone would like to use OpenVG for vector graphics acceleration, and adoption is picking up, as you have seen from my slides. We don't have to initiate a new work group. The work has to be done by OpenVG work group, existing OpenVG work group, most probably under initiative of Dr. Hwanyong of Hwanyong. Investigation is being underway or conducted for which key features to remain and how we optimize OpenVG function sets for better and easier implementation on one device, which is OpenGL. And our major target applications will be SVG Tiny 1.x and Flashlight 3 and 4. And according to Hwanyong, Alex VG Study Kit will be soon available for KITE utilization. And by introducing OpenVG Lite Profile, which is the correct name for OpenVG, lighter set of OpenVG, users will have a better choice of running both vector graphics and 3D on one device. So thank you very much, and if you have any questions.
As far as I know, OpenVG is based on vector, but from my observation to the silicons, many silicons still have a 2D API based on a raster, and I mean they may use some very basic functions like bit bleed or stretch bleed or rotation or things like that.
Like a sprite engine. Right?
Yeah. Raster-based 2D engine is very common in nowadays silicon. So does Khronos has a plan to develop a standard API for these kind of functions?
Well, Neil, what do you think? And why?
The OpenVG does have that functionality. So VG is not just vector graphics. It has splitting, it has stretch splitting, it has composition, quite sophisticated composition functionality beyond OpenGL. But I'm interested in Tom's view because OpenGL also has 2D sprite capability. So if you have OpenGL on your system or OpenVG on your system, you already have the 2D raster type operations.
I think it's actually a really interesting question, and it comes back. We've had this question before and discussed, and it's the reason the question does not go away is because it is very interesting. Yes, you can do hardware blitz in ES2, or you can do it in OpenVG. You can do many ways you can do it. In general, so far, we haven't seen clear proof that it's needed to have a separate API to deal with that. There are issues with using those APIs, though, for kind of OS-level blit functionality. It has even occurred to us that OpenCL is a reasonable way to do composition-type operations. The main problem is the coarse granularity, that none of these APIs are very good for a very small operation. If you want to blit a character to a screen, it's typically not wise to do it using it's a good job for software. I think this is still an open question if we need something else. We had the question very early in the life of Khronos with respect to Java MIPI, where there was a clear need and the 3D API didn't seem to meet it. I'm still interested in it, but I don't see a good way for Khronos to expose it right now. But I think more ideas are would be useful.
I agree that most of the REST-based 2D functions can be done with OpenVG or OpenGLES. But the problem is that for the embedded device, the power consumption is a key issue. So for the GPU cannot do the REST-based 2D functionalities very efficiently. So normally, many silicon vendors use a standalone 2D IP. But so far, there is no standard API for this kind of IP. So they all use a proprietary API.
Yeah, it's actually an interesting point.
Yeah.
So it's that, and you say the small granularity. It might be ironic that the Blip API is the last one that Khronos does.
Thank you for a very useful and stimulating question. Now, let me hand the mic over to Eric.
Okay, I'm Erik Noreke. I'm the chair of the OpenMax AL and OpenSLES working groups. I'm going to tell you a little bit about these two APIs and also a little bit about what's happening in Android. But first of all, the big question that we always get is, why did Khronos decide to create multimedia APIs? There's plenty of open source frameworks out there, and is there really a need for the Khronos APIs? Well, one of the differences is that with open source frameworks, you're free to change the content so that anybody who uses an open source framework can download the framework, implement it in their device, and they change the source code. That means that as an application developer, you never know how things are going to function on one device to the next, and if you're going to have to port your software. The Khronos APIs, they provide performance tests to ensure that the functionality on each and every device is the same, so that you do not have to port your application. The open source frameworks tend to be unique, where as a manufacturer integrates an open source framework, they will change things. They will think, oh, I can do this a little bit better. I can do that a little bit different. The Khronos APIs, like I mentioned, they're really focused on making the platform portable so that you can move your application from one device to the next. We also provide the IP protection of the Khronos IP license that Neil talked about earlier. The open source frameworks are generally released under some form of the GPL license. There's various forms of the GPL license. There's also other open source licenses. But the licenses do tend to provide or come with a few hooks in them, especially the later GPLs that really make it difficult for integrators to isolate their IPs from the general purpose license. With the Khronos multimedia APIs, we decided to do profiles and components as opposed to plugins. With the profiles, we can the application can be developed for a specific subset, and it reduces fragmentation. The plugins, they tend to be a lot of plugins for the multimedia frameworks, the open source frameworks, and as an application developer, you never know which plugins are going to be on any specific device. So with the Khronos APIs, and not just with the OpenMax AL and OpenSLES APIs, but all of the Khronos APIs, you get a predictable set of functionality. Whereas with the open source frameworks, you get a functionality that is dependent on the implementation. So with OpenSLES and OpenMax AL, we're looking at application access layer. These are the layers of APIs that an application developer, a game developer, for instance, are going to access to get multimedia functionality. So there are lower layers in the software stack that provide the same functionality that the higher level APIs do. The problem is that they tend to be very complex, and it makes it difficult for application developers who they just want simple multimedia functionality. I want to play my sound, I have a background sound I want to play in my application, and just here's my sound, when we hit the play, just repeat and go. I don't want to have to set up a complex multimedia chain to enable it. I want to have simple configurability so that I can tell it, I want to do this, that, and that, and then just fix it, do it. I want to spend my time on making my application, on developing my application further rather than trying to figure out the complex underneath multimedia system. So when we looked at developing OpenMax-AL and OpenSLES, we made it simple for the application developers to do rapid application development on top of the multimedia platform. And we wanted to make sure that we provided portability from one platform to another for software developers, so that you don't have to rewrite your application every time. With these two things in mind, we set forth to develop the two APIs. OpenMax-AL is focused on streaming media. It's media playback, media recording, video files, radio, camera input. You get a full range of video controls, including playback rate, post-processing, image manipulation. You can get the raw data to manipulate if that's what you're interested in. And it allows you to apply effects to capture images and videos, for instance, before sending it off to your friends or before rendering it to the screen. So OpenMax-AL is designed to give easy access to streaming media. Like most multimedia frameworks out there, the open source ones, OpenMax-AL provides a complete set of multimedia functionality. OpenSLES is designed for mobile audio. And when we took a look at what are the devices, where are devices going with audio, we talk a lot about video. Video is sexy, it shows up nice and then color add and so forth. Audio is really hard to really present to the user except for putting on those headphones and listening to them. A lot of things are happening in devices today with audio, and OpenSLES is designed to give access to all that powerful audio subsystems that are in the system to the application developers in a simple manner. So they give you full range of 3D effects such as Doppler, virtualization, and it allows you to create theater quality audio experience in a mobile device. So when you look at 3D audio experience, you really it's a perfect companion to OpenGLES. If you're looking at a 3D game without the 3D audio, you're not going to get the full 3D experience. And the audio complements the video, the graphics, so that you really get drawn into that the game or the application. And with an API like OpenSLES, it's designed to allow you to take full advantage of the system capabilities, whether they're rendered in hardware or in software. To make it easy for the application developers, we designed it with using object-oriented capabilities. So it's simple. You define where's the audio or media coming from. You have your player object and where's it going. And then you manipulate it. Play, record, etc. Makes it really easy to set up the simple use cases. But it still allows you to build up the complex functionality and the complex controls that are needed in certain cases. So when you look at these two APIs and the graphs that you build up using them, the object structures, they are similar, and actually the common parts are the same. And when we looked at OpenMax-AL and OpenSLES, we designed the common parts together, and the two work groups actually work together to ensure the compatibility between the two APIs, so that if a device manufacturer decides to implement both of these APIs at once, that they can actually make it so that you can take the OpenMax-AL video, send it to the video system, take the OpenMax-AL audio, and pass it on to OpenSLES and manipulate it that way. When you look at the functionality between the two APIs, OpenSLES concentrates on audio, the advanced audio. OpenMaxAL is the more, I shouldn't say simple, but the more common parts of multimedia rendering. So audio playback, also adds video playback and all the video manipulation techniques. So that the common parts there, the audio playback, the audio recording, and the basic MIDI functionality is common between the two APIs. We also provided the profiles to make it easy to adapt an application. So an application can actually query the various profiles of OpenSLES, for instance, whether it supports the phone, the music, or the game profile, or a multiple of them, so that you can code your application to a specific profile, reducing the fragmentation in the marketplace. The same thing is true with OpenMaxAL, where we have the player and the recorder profiles, so that a device may be, for instance, a music player may not have the recording capability, but it will have the playback capability. So we did this to reduce fragmentation. So for device manufacturers, they only need to support the profiles that they need. For the application developers, they can target or they can query the profiles that are there. They can actually adapt their application to the profiles that are present. And it facilitates the porting of applications, and applications can actually handle so that the profiles, you query the profiles. If you have the full game profile in OpenSLES, you can do the full range of audio effects. If only the phone profile is present, you render it in simple stereo. So there's also a few optional features in both APIs which the application can query for the same way. These are the functionalities that only a few devices are going to implement. So if your application feels that those are necessary, you can query for them, and if they're there, you can use them. So, and as I mentioned, these two are designed to work together, and there's been some discussion, and I often get questions about this too. So why not combine the two into one API if they're so common? And the reason why we do not combine them into the one API, well, first of all, OpenSLES is a 600-page specification. OpenMaxAL is about 500 pages. I'm pretty sure most people would find an 1,100-page specification daunting and just wouldn't want to get into it at all. The other thing is that we want to keep them separate so that you really can concentrate on the advanced audio functionality with OpenSLES. You can work with OpenMaxAL to have the multimedia functionality and controls. But at the same time, as you combine the two in a full-fledged 3D multimedia system, they are compatible so that you can use them as one API or individually. So it really enables the market to select what they need. So when we look at a complete multimedia use case, and I notice my animation on this one is off. One of the things that we recently did is we have the OpenMaxAL EGL stream extension that allows you to pipe the graphics information from OpenMaxAL to an EGL stream so that you can put it in an OpenGL texture and render it in as any 3D texture. This allows for really interesting things when developing your games. You can match it up with your 3D audio. For instance, if you're coming into a room in a game and you have a video playing, you can project it onto a wall as a texture. And it makes for easy rendering of some really neat effects in games. So what's happening in Android? This is also a question that we often get with Android NDK being released in 2.3 in Gingerbread. And they're using a lot of the Khronos APIs. So we get questions about, where is Android headed? What's Android doing with our APIs? In 2.3, Android released OpenSLES for audio, OpenGL ES for graphics, and EGL for the graphics system. One of the things about the NDK that when you develop resource-intensive applications, games where you need a lot of control and better functionality, the Java APIs really didn't provide the functionality and the control that was needed by application developers. There needed to be better coupling and access to the hardware acceleration. And multimedia is the primary reason for the NDK. When they released the NDK, it's multimedia that was the first focus of for Android. There is a downside to the NDK as well. It increases the application's complexity. So if you're writing a simple application in Android, you're probably not going to dig into the NDK. It does require that you compile for the platform families. You have to build up your libraries. You have to make the context switch. And it does increase the complexity of your application and development. Android is focusing on standardized APIs. We're seeing them addressing the functionality that they need. They had internal APIs before. They decided to take the Khronos standardized APIs and put on a layer on top of their previous functionality. This is so that they can avoid fragmentation. Our APIs are well tested. They are well documented, so that there's complete documentation available for our APIs, and there's also a lot of developers out there who know how to use them. This way they could focus on the functionality and not on the actual implementation, and also gives them an easy way to couple. For instance, OpenGL ES has coupling to the hardware acceleration that's already in the device. So in 2.3, we have OpenGL ES 2.0, EGL 1.4, and OpenSL ES 1.01. They have, for OpenSL ES 1.01, they have a partial implementation. It's not a full implementation. It's almost a complete phone and almost a complete music profiles, but it is not complete profiles. They also added the buffer queues from 1.1 as an Android-specific extension. As far as the Google version of the implementation, and this is one of the things with Android, is that each company that implements Android on their device, it's an open source project, so they can go in and change things. But as Google releases Android, the APIs are compliant with the portions that they have for them. So, and there are other vendors out there that offer fully compliant solutions to the Khronos APIs. So, in Ice Cream Sandwich 4.0, we have, for the first time, the same OS for both phones and for tablets. It has better support for multitasking, for hardware-accelerated graphics. They added DRM, and they added a partial implementation of OpenMax AL 1.0.1. For OpenMax AL, they did also add the buffer queues. It's a streaming use case only implementation, and they decided not to have it interoperable with OpenSL ES in this release. There's also OpenMax IL in Android, and Android uses OpenMax IL in their multimedia frameworks. It's for codecs. They use it for implementing codecs. It's not for graph building. So the main multimedia framework is still Stagefright. The important thing to remember about OpenMax IL is it is not part of the NDK, so it's not accessible for application developers. But if you are writing codecs for Android, OpenMax IL is an easy way to integrate them. Now, one of the questions that we frequently get is, so what's Google saying? And people really expect Google to go out there and say, yes, this is what we're doing, this is what's coming in the future. Google, on the surface, seems like a very open company. Unfortunately, that's not quite the case. Getting information out of Google about what they're planning is extremely difficult. when you ask them direct questions, they kind of shrug their shoulders and say, well, you'll have to see in the next release. Okay, great. So we can make educated guesses. We can take a look at what they're doing, what are their actives, and this is one of the great things about being active in the working groups, working together with companies like Google, is that you can kind of gather what their interest is. So we know that Google is interested in seeing Android on more devices. Will we see it in TVs, netbooks, or Chrome OS also? Where is that added? Are they going to merge Chrome OS and Android? We'll have to see in the future. Also, we'll have to see, will they actually do a fully conformant OpenSLES solution? Will they give us better OpenMaxAL support? Will they support EGL stream extension, OpenCL, and content pipes? These are all things that, we'll have to see. And one of the reasons to get involved in the working groups is you can get kind of a feeling for what they're interested in going ahead. But really, you'll have to wait for the next version of Android to find out what they're doing. Okay, thank you. Any questions? Tom?
So I spent a happy week at the Game Developer Conference in San Francisco last week. One thing I went to was a number of talks on gaming in HTML5. And there were a couple of takeaways that every talk I went to, everyone agreed that it's very exciting, it's very promising, and that audio is broken. And so I'm thinking, they also agreed that the best implementations of HTML5 gaming out there by far are in the Chrome browser. So it occurs to me that now granted that probably the Chrome browser guys and the Android guys hate each other, but still the case that it would make sense, given that OpenSLES is fairly well supported on Android, to consider a WebSL implementation of some sort. Do you think the API is appropriate for that? And do you think, can you see any way to, given that we don't create web standards really, we have groups that work with the web to create things like WebGL and WebCL. But do you think a WebSL is a possibility or a sensible thing?
Well, when we look at OpenSLES and porting it to JavaScript, I think it could be done programmatically. You could actually write a script that converts the OpenSLES specification to a JavaScript specification. That being said, there are also several other groups out there working with audio specifications for the web.
Mm-hmm.
We have communicated with Google, the Android people at Google, and their interest is lukewarm at best.
Mm-hmm.
And we've brought it up several times in the working group. It has not proven to be something that people get excited about. And because of that, we have not put the effort in.
Okay, fair enough.
But I do agree that OpenSLES would be a great foundation for a web standard.
We should talk about that again. I agree with Tom.
Yes.
Because the Chrome team has web audio.
Yes.
Ken personally is quite involved. He's friends with the guy who's developed it at Google. He promotes it at every opportunity. But it's not a done deal whether Mozilla and Safari are going to adopt it. And perhaps we have a
window of opportunity
to build out let's just build these native APIs up into JavaScript.
Exactly, yeah. I'm always interested in taking the conversation. It wouldn't be the first time.
Sure. Because I think Android is going to be pretty soon. This is public knowledge, right? Chrome is coming onto Android pretty soon. I think the browser focus of opportunity is going to be around the Chrome browser, not the old crummy Android browser that we've had in the past.
Yes. Yeah. Any other questions? Okay, thank you.